Okay, in this lesson, we're going to go ahead and talk about how to graph linear equations. So we're going to start off with a little bit of a review on plotting points. So remember a coordinate pair, -2, 4. You would go over to the right 2, because it's negative, you'd go to the left 2, and then you'd go up to 4. So that's a coordinate pair. 0, 0 is called the origin. The x value is called the abscissa. The y value is called the ordinate. We plot points by using the x and the y values of our coordinate pair to go ahead and plot. Points on the x-axis are called the x-intercepts. Points on the y are called the y-intercepts. Remember, a function, a relation is just a set of ordered pairs, but a function is a little more special in that every x value has one and only one y value. Domain is your set of all the inputs or the x values. The range is the set of all your y values. A linear equation is one that's written in two variables, and it will reproduce a line when graphed. So this is if you remember, we talked about in our last section on literal equations, y equals mx plus b. This is going to give us a graph. The standard form of a linear equation, however, is ax plus by equals c. For example, we have 2x plus 5y equals 8. We can go ahead and replace the a, the b, and the c with numbers, and that will create its own unique line. Solutions are a set of x and y pairs that make the equation true. One solution is -1, 2. So let's see, if we were to plug that into this equation, I would put the -1 in for x, I would put the 2 in for y, and what we're hoping for is this to be a balanced equation. So let's see, 2 times -1 is -2, plus 5 times 2 is 10. Does that give me 8? When simplified, it does. That's why -1, 2 is the solution. I can plug an x and a y in there to make it balanced. You prove it by checking it out. Are there other solutions? How many? Well, let's see. In order to figure that out, we graph it. We're going to go ahead and check whether an ordered pair is a possible solution to this equation. 3x minus y equals 7. So we're going to go ahead and test out 3, 4. We're going to test out 1, -4. So we have 3, plug in 3 minus 4. We're going to see if that equals 7. 3 times 3 is 9, minus 4 should equal 7. 9 minus 4 is 5. Does that equal 7? No. So this one is not a solution. Let's test out 1, -4. Same thing in the same equation. So we'll have 3, plug in 1, minus, plug in -4. Should equal 7. Let's see, 3 times 1 is 3. And then it says minus -4 equals 7. Be very mindful of your double negatives. So that's really 3 minus a negative. 3 minus a negative is the same thing as plus. Does 3 plus 4 equal 7? It sure does. This one is yes. It's a solution. Okay, so we just test out. We plug in. If we want to graph a linear equation, we can make a table of values and plot a bunch of points and then connect the dots. That works. That's a pretty easy method that we can all try. So here we go. We've got the equation in y equals mx plus b form. Y equals mx plus b. So this is the form that we're going to write our equation in. It says make a table of values. Plot the points, connect the points. Okay, let's do it. I plug in -2 into this equation. So you would want to go ahead and show your steps here. 2, plug in -2 plus 3, and then simplify. 2 times -2 is -4, plus 3, that's going to give me -1. So that's my y value, and then I go ahead and plot that point. -2, whoops, I drew on my graph. Let me go back. -2 and then -1 would be right there. That's 1 point. Then we're going to go ahead and plug in -1. So I've got 2, plug in -1 plus 3 2 times negative 1 is negative 2. When I add 3 to that, I get a positive 1. So let's see, that's negative 1 up 1. Let's try 0. 2, plug in 0, plus 3. 2 times 0 is 0, plus 3 is 3. So 0 up 1, 2, 3. Keep in mind, you're graphing lines. Anytime you see an equation in this form, you should end up with a straight line. We're going to go ahead and plug in 1. So I've got 2 times 1 plus 3. That's 2 plus 3, so that's 5. Over 1, up 1, 2, 3, 4, 5. And then we'll go ahead and plug in the last one. 2 times 2 is 4 plus 3, that gives me 7. Over 2 up 7. So you're not done. We want to go ahead and connect the points. So draw a line through your points. Don't just stop at those last 2 points, and then put an arrow on either side because this is a line. We're graphing linear equations. All right, here's your next example. So we're going to go ahead and fill in our chart. It didn't give me any x's, so guess what? You get to pick some. You get to pick some. I would pick negative 2, negative 1, 0, 1, and 2. They look pretty good to me, and they're easy to plug in. So if we go ahead and plug this in, I'm going to do it mentally. You do it either mentally or on your paper. Okay, your chart should look like mine. Yes, this is a function. I don't see any repeated x's, and when I take a look at my graph, I can drop my vertical line in there, and it will pass my vertical line test. Let's take a look at the next example. Y equals 3. Okay, I don't see any x's in my equation, but it does say the y has to be 3. So in my table, I'm going to put 3's in here for y's. All of them. And again, you get to pick the x's, so I'm going to go with my trusty negative 2, negative 1, 0, 1, and 2, and go ahead and plot them. So negative 2 up 1, 2, 3. Negative 1 up 1, 2, 3. 0, 1, 2, 3. All right, this is creating, whenever I see y equals a number, this is going to create a horizontal line straight across my paper. Is that a function? Yes. You can drop a vertical line in there and it's only going to cross the graph once. Our next one says x equals negative 2. Okay, they're telling me my x has to be negative 2, so I'm going to go ahead and put that in here. Well, if you notice, I don't have any y's in my equation. So I can't plug anything in and calculate, but you get to pick the y's. So again, I'm going to go negative 2, negative 1, 0, 1, and 2. And when I graph it, it's going to look like this. Anytime I have an x equals a number like this, you're going to get a vertical line. Does that pass the vertical line test? Well, we just plotted all of our points. So when we dropped that red vertical line in there, did it touch our points in just one spot? No, it touched all of them. So this one is not a function. It fails my vertical line test. We can also limit the domain, and that will change the way our graph looks. It's also going to change what happens to the range. So we'll take a look at a couple of examples there. It says y equals negative 4x minus 3 with a domain of x less than or equal to 1. So that tells me my x's have to be less than or equal, I'm sorry, I said less than or equal to 1, less than or equal to 0. So I'm going to start with my first x, 0. And then I'm going to go negative 1, negative 2, negative 3, negative 4. We've limited the domain, so we're going to end up limiting the range. Go ahead and fill in your chart and graph. Okay, I've got all my dots up there. I had to put my last one sort of off the graph here, but I went ahead and graphed them. And now I don't want to just randomly draw my line through them. I want to be very mindful. I had to restrict my domain so that the x's had to be less than 0. That means when I graph it, I shouldn't see any part of my graph that's greater than 0. So I shouldn't see anything over here. I shouldn't. So when I drop my line, I'm going to actually start at 0 and go in the opposite direction. This is my graph for this one. And we practice writing our range in set builder notation, so we're going to go ahead and do that. Y such that the bottommost point of my graph, the bottommost point is at -3, less than or equal to y. And I don't have a topmost point, so that is my domain, or that is my range. My range was limited to x is less than or equal to 0. Let's try another. Here we have -1/2 x plus 1, a domain that has to be greater than or equal to 1. The tricky part here is that I have a fraction, so I want to always choose x values that are a multiple of that denominator. So I'm going to choose, and it has to be greater than 1. So I'm not going to pick 1 in this, well, I can, yeah, I'll pick 1 in this case, but then I want to go, 2, 4, 6, and 8. You get to pick whatever you want, but we want to limit it so our x's have to be greater than or equal to 1. So I am going to plug in 1 first and the rest. Go ahead and do that. All right, so I went ahead and filled in my chart. It was hard to graph 1 and a half. I had to go over 1 and then just up a half, so that's why you see that point in the middle there. And then I've drawn the rest. Again, I want to be mindful of my range. It says the x has to be greater than 1, so here's 1 on the x-axis. So greater than would be to the right. So I'm going to start at this dot and just make sure I go to the right. What would be my range? Give a little squiggle there for your braces. Y such that. Do you have a bottommost point? In this case, no, it keeps going. So I'm not going to start with a number. I'm going to start with y. And I'm going to go less than or equal to. How high up did we go? We went up to 1/2. So that's graphing using a table of values. So you want to just choose wisely what x's you want to pick. Plug all your x values into your equation, show your work, and get your y values, and go ahead and graph. You can draw your points and then a line right through your graph. You can do that unless we have a restricted domain. Then we just want to be careful that we draw the right graph in the right direction and correctly label our range.